Hi there. Apologise for the wobble. The tripod isn't the best, but we're getting there. Anyhow, I haven't had a video on for quite a while now, and I haven't had a lot to put on, to be fair. This has been taking a lot of time, and this has been taking a lot of time. So, winter in the UK is very cold. My garage is not finished. Heating it is pointless when it's -2 outside. It's now getting warmer, so I'm getting back up to go back outside. And I was getting annoyed about the little amounts I can do inside, contributing to what's happening outside, which is finishing the garage off. The reason why I'm finishing my garage off first before decorating the inside of this room here and other decorating and stuff like that is because a functional workshop makes everything easier. Plus, I am attempting to make a nuclear fusion reactor different to the typical fusion reactor that you see, which will be either a tokamak. They're trying to do compression, ignition, and both laser compression and dust compression ignition fusion. Well, I came up with a new idea and I'm going to try it. And this is where my workshop journey started from. Building the workshop the way it is, with lots of fancy milling machines, lathes, CNC stuff coming in, you know, all the bits and bobs that you need to make the components to make a nuclear fusion reactor. They're not that complicated unless you go in big scale. Anyway, it's cold, not doing anything out there, so I wanted indoor stuff to do. I didn't know I wanted a 3D printer, but I got one anyway, so I got the cheapest one I could, and that'll be this CTC10s. It's, you know, it's not bad now. Now I know its limitations. It's not 300 by 300, it's 100 by 100. It prints okay, and I'm slowly upgrading it, bit by bit. This is one of the things that I've made, which is just bitting and bobbing, which is a new hot end. It's going to go in here. I don't know if you can see it. Yeah, you can, just about. There you go. That's going to sit there and squirt the plastic out. So I'm making that new hot end, and once I've made it, I'm doing it in CAD design on Fusion 360. Then I'll be able to knock a load out. I have plans for this. This will do 4 colours or 4 materials. So I'll have 4 of these sitting up here somewhere, going up and down with the head, and then they will change. So there'll be some kind of changing mechanism. Anyway, that'll make 3D printing easier. Also, I wanted some fun, so I got this RC car. I might put some of the initial footage in. I was going to do a whole video about this RC car, but it doesn't seem worth it. Now, the reason why I'm not doing videos is because this, really. So, I've got a new body shell for this. The original body shell is up here. Let me just grab that. So, this is a Wltoys. Probably recognise it with that body shell on. So, it's a Wltoys vehicle. And I have this body shell here, which is a Mark II Escort. I'm just doing that at the moment, cutting it out, getting it ready for paint. But first of all, I want some mounts, so I'm making my own mounting system. There's quite a lot of upgrades on this already, and the front mount, as you will see, there is 2 holes drilled in the body already for it. Probably see it already, but you can see it better with my hand underneath it. There's a hole there and a hole here. Well, they fitted into that was fitted, all drilled and tapped, but slightly wrong, so I've had to update the CAD and then just flare it back a little bit. This should be bang on. So I've gone through initial prototype, measuring the gap, second prototype, thought I'd got the gap right, got the angle right, wasn't quite right. Third time lucky, it was absolutely perfect. Drilled the holes in the wrong locations, and it really needed about another 7mm height. So I got 7mm extra height, and I moved it back. So, you know, these take an hour to print because I'm doing 100% infill, and it's all just boring printing stuff. Basically, it's just 3D printing over and over again. So there's no point in going over it. Now, I should have done a video really on the aluminium arms on this, fitting all the aluminium suspension arms and all the upgraded parts, because when the arms come on this car, the aluminium upgrade arms, they are an aluminium downgrade as far as I can see, because you just get extra slack in your suspension. So you go from having a little bit of slack, which this is the genuine steering. I don't know if you can actually see, you probably see that's just steering slack. That's from the standard arm up here, which I'm going to have to, the last modification, hopefully. That's standard. This one's got no slack in it at all. When I put these on, we had camber slack of around about 8 degrees. Well, 12 degrees I should say, the worst. Best was about 5 degrees, but they all had camber slack. On top of that, you had wheel bearing slack, which added a between 4 to 6. So yeah, the worst wheel probably had about 20 degrees of slop side to side with those two. And then with the aluminium arms being so slack on the pins, you had about another extra 2 degrees. So you get into a real massive angle that the camber would have just fallen backwards, and that would affect the track as well. So I took most of that out now, and I think we've got around about 5 degrees of slack in the steering on that side, nothing in the steering on that side, a slight wobble in camber on that side, and that's what I'm going to show you now. So this is an aluminium upgraded lower arm, and yes, I've got multiple packets of these things because I'm going to break them, and I am getting through them. I'm not very good at driving RC cars. I tend to smash them to pieces. So, this is the front arm. I know it's the front arm. I just made sure before I come in and started this video. And this is the front steering knuckle. This is called a steering knuckle on any vehicle that's on the road. It's a car. And that should slip in that area there. And as you can see, this one doesn't. So I'll have to fit it, which will mean taking some material off the side of the knuckle and fitting it in. Now this one is exactly the opposite. It slips in and it's like a spoon in a pudding bowl. It is sloppy as anything. So I ordered these to take the slop out. What that slop was, that was a caster slop. So that would give you a caster slop because it was so sloppy on the pins, and now I've took all that out, majority of it. And this was all tedious stuff, and it's very hard to film. So for instance, because this pin, oh man, where's the pin? Let's get the pin out, come on baby, pin, come out, don't fall out, there we go. So this pin goes through that bottom arm. Ooh, that dropped it. And right now we have slop. I don't know if we can, you're probably seeing that slop there. So to take our slop out, I was planning on putting that in the milling machine, drilling it out, bushing it with some brass or bronze, and then drilling and reaming it to a perfect fit. But what I actually did was I got some aluminium foil, I wrapped it around the pin so it was really tight, so many wraps, and I put too many wraps on for a start, and I slowly cut off bits of wraps, and then I brought it off the end of the pin a little bit and just flared the end down to a little point. Ooh. And then I fiddled it in until it went in, got it about halfway through, put some Loctite around it, and then pushed it the rest of the way through and left it to dry, and then pushed the pin all the way through to take that little pinch bit off the end of it. So then this was sleeved with a piece of aluminium. Now I did that to all the steering knuckles, well, both front steering knuckles and both rear stub axles, which are very similar to the knuckles. And I also did it to all the bushing points on there, on the lower arms. So that took all that out. What that did for me, and this was just too tedious. It was just trial and error, and it was taking ages. What that did was, these arms would move backwards and forwards tremendously. Now you can see there's a little bit of slop in it now, and this one still needs, well, you say shimming. You can still go forwards and backwards, and that's the two pinch points which are grabbing that pin. I can just squeeze them together with a pair of pliers and bend to the car's part, but that's another story. Every other piece of play apart from that has been taken out, so there's no axial movement like that, there's no flexing of the arm backwards and forwards like that, there's only lateral movement forwards and backwards on the axis of the pin now, and there's nothing on that back wheel. There is a bit on that back wheel actually, and oh yeah, that's because I haven't done the rear stub axle lower pin yet, the one that I just showed you. I haven't done the rear one yet, I've already done the front two. These are taking ages, and it's just like, I can't film it. So that's been taking ages. The other thing was, I've upgraded all of the electronics in here, and then I've got another body which I'm halfway through, and all these things take me ages because I like to sit there and think about it and then do it. And oh yeah, you can see I'm marking that up for paintwork at the moment, the paint scheme that I'm going to be doing on it. You can see all the lines on there. I'm just doing rough lines, and then I will mask it all out and spray it all in the colours that I want it. Oh dear, and this needs a bigger body on it now because the new electronics don't fit in. So this thing is tremendously fast now. It came pretty fast. These are pretty fast straight out of the box, 30 miles an hour ish. And as it was, this was 60 mile an hour ish. Then I tried this being a 3-cell or a 2-cell system, so they call it 2S or 3S. That's in series of lithium polymer batteries. I ran it on 2S for well, quite a while, and it destroyed all the wheel bearings inside it. Literally ripped them to pieces. And then I put 3S into it and it blew up. So I'm through a warranty claim at the moment. Now I'm getting my Escort body fitted, and we're going to do some speed tests on it on 3S because I'm getting the new controller coming through, and we'll be able to push up to about 90 miles an hour ish. It should be geared to about 90 miles an hour. So I'll be having some fun with that, and these are the reasons why I haven't been doing any videos, because it's all too tedious, too small, and I'm doing a lot of umming and ahhing and backwards and forwards in, and don't really know what I'm doing, so there's no point in saying any of this stuff. But I may do a full review of all the parts which I've upgraded on this to make this so much smoother once it is completely finished. But I just wanted to get a video out to explain why I'm not doing anything at the moment video wise, and I am doing stuff, but I'm just not doing stuff video wise. Take two. Right, so in my attempt to make this do over 100 miles an hour, I've encountered a few accidents. The previous accident to this one was this one. I hit a concrete wall head on at probably 30 or 40 miles an hour, and it pinged off one of the lower arms, bending the CV joint, the constant velocity joint, at the same time, I hope, and ripped the back plate out of the gearbox, stripping the threads out, and cracked the differential casing and ripped that off the chassis and bent the chassis. Here is the chassis. There's the pressing marks there. You can see where I put a clamp in to straighten it out. I do have a new chassis, but I've managed to straighten this one out and now it is straight. So I rebuilt it, improving it all the time. So these metal arms are pretty rubbish, but you can see my pins in there, moves freely but doesn't fall out. That's because I've got aluminium foil wrapped around and Loctited in position as a bush, just to make it better. And it does, it makes it a lot better. Steering is precise. So this accident, I was doing approximately 55 miles an hour. I put the brakes on, it slid sideways into a curb because I was trying to get the last bits of miles per hour out of it. 2S battery, lithium polymer 2S. Anyway, this is what happened. It pushed the back plate off this axle, ripping the threads off of it, off this differential casing, ripping the threads off it, bending the keeper plate and breaking two plastic bushes. Let's have a look inside. So I was running CVDs on the rear axle here, just trying them out. First thing it does when it does this, because it's so solid now, is it bends the CVD. And that means the CVD will not come out. I'm sure this lock will. There we go. So now the CVD won't come out. Oh, it's going to make me a lie. Yeah, it's made me a lie, so it has come out. Anyway, it's bent the shaft on that CVD there, because the wheel's wobbling. For these, I have a spacer there, because the bearings aren't the right size, so I've made spacers on the lathe. That bearing there is a standard bearing. That bearing there is 1mm bigger and 1mm wider, being at 8x3. This came with 7x2s. I now have the 7x3s for the outer bearings, so I'm going to run 8x3s and 7x3s, and then I won't need to have that little spacer. This rear axle, this rear arm, sorry, apart from me having to hacksaw it to make it into a flat blade to get it out, that's been bushed up as well, so there's no, well, there's a bit of play on this side here, and I figured out how to get that play out, and that's on this axle here. Let's see if I can get that one out and show you. This is running CVDs this side. So I run Loctite on everything, so to break the Loctite down, I've got a little bit of spirits. I want to keep that off the glue on the tyres, because that will deglue the tyres as well as degluing the Loctite. Let's take a look inside this wheel here, if we can. If we can't, no, the Loctite's too fresh. So I'm not going to show you that, because that's too difficult to undo. You'll have to take my word for it. So what I've done is, instead of using the little keeper screw there, that you see just there, I have eradicated that screw, drilled and tapped 2 M3 holes there, and then put grub screws in, or set screws in, and then that takes that last little bit of play out, which you can just about see on this pin here. It's hard to see, but there you go, I'm sure you saw it. So that's what happened with that accident. Looks like the inner bearing's alright because it is a sealed bearing. Now, getting this whole thing off of the chassis, I ended up not heating the threads up in that, and I'm going to screw off. These are the things I'm getting up to. Highly entertaining. So here is some of the stuff I'm doing. Upgrades for the 3D printer. That is these two pieces of aluminium. I just cut these down today, took quite a while, nothing spectacular. They're within 1/100th of a millimetre of each other, which I think is going to be close enough. Should be pretty square at that. Should be. So that took me a while to do those two bits of aluminium today, about 2 hours. This is the hot end that I was showing you. So I'd put the screws in, 4 screws here, and I'd set up the height of the heat break and the length of the nozzle. I've made a top keeper plate to push the cold end, which you might be able to see through the fan there, down and press it hard against the heat break. Then I wanted the cooling fans, and I am going to make a proper, even more lightweight version of the cooling fans than this, and way more compact than this. But this was very easy to make today. It took a long time to cut all this. This was a David Beckham deodorant can, which you can just see a little bit of the writing in there, maybe. I don't know. It says home next to that wire there. You might not just see it there. And then I've heat shrunk these wires bit by bit, using the heat shrink to mould into the area I wanted to. Hand drilled all these holes into sheet steel. Oh my, that took ages, absolutely ages. And did the final fit on the heater block for the temperature sensor and the heating element inside it. So that's ready to fit more or less. When I say more or less, that is because this unit here has got to be integrated into it. This is what they call a Wltoys, and you're supposed to mount it somewhere in here, somewhere like that, but I'm not going to. That's the back face that usually goes and bolts against the 3D printer. What I'm going to do is I'm going to put the Wltoys mount on the 3D printer, put a heat shield in front of it with a mounting bracket for these to quick fit on and off, probably some kind of magnetic snap fit, so it'll just snap on, click, and then it'll be perfectly aligned on 3 ball bearings or 4 ball bearings or whatever it is that you do to make those. They're called telematic joints, what they're called, kinematic joints, I think they're called kinematic joints. So I'm going to make a kinematic joint. So I'm going to mount this square on the 3D printer on the X-axis, and then that's going to go onto it. So this is going to be my final design, and I'm going through it bit by bit, and today I've just come up with that, and I think that's going to be the best, because when that's mounted like around about that kind of distance apart, look how close. You just can't get the tip of the Wltoys any closer to the nozzle than that. That is the closest you're going to get. The other option I'm going to think about, this is what I was going to do for a start, was to mount the touch up here. I know this one's the cloned version, the 3D touch, but I was going to mount this here somewhere like that, and then an extension, modify this, the sticky outy thing, so it came down so it would literally be right next to the nozzle. But today, when I was nearly completed this, it suddenly came to me, mount that behind there with a heat shield. So top down you'll be looking at it, this will be mounted to the printer like that with a heat shield, and then this will be mounted to the heat shield area like that. So that's another thing I've been doing. These here marked out here are almost equivalent to this here, but a little bit longer. The reason why these are a little bit longer is this is the chassis for Wltoys 144001, and I am slowly fitting these metal differentials bit by bit. They take some fitting. Anyhow, you're just looking at those arms with the bushings in, and they go somewhere around about there and somewhere around about there. And there'll be a keeper plate which bolts to the back of the differential, and a keeper plate which bolts to the front of the differential. So the idea of these two keeper plates is the pins for the arms are pinched in the keeper plates, and when I have accidents at 40 or 50 miles an hour and hit stone curbs or concrete curbs, they're quite hard and this comes to a sudden stop. It doesn't matter how good your car is, you try and drive your own car into a solid brick wall at 50 miles an hour and see what happens to it. These things break. So I've slowly been going through all the bits that are weak on this car, and I'm finally down to these are the weak points now. These keep on breaking, and when these break, it's a complete strip down. You've got to take the entire car to pieces to change this, or to get it out and bend it back into shape again. So that is a pain in the backside. So I'm making them out of 5mm thick aluminium. The idea is that the longer ones down here will stick out a bit further than this. As you can see, they stick out quite far, but they'll stick out just a little bit further, and I'll be able to drill and tap a thread up from both sides, and then there'll be a piece of titanium underneath the chassis which goes from the rear here all the way to the front, bolting into each keeper plate as it goes, and they will keep the distance between the keeper plates as solid, so these won't be able to move. So the only thing that will break now will be the pin. I should imagine the pin will break now. I've already broke one pin, so I think the pins will start breaking now, and I can handle the pins breaking because I can just take the rear keeper plate off, slip a new pin in, put the rear keeper plate back on, and away we go again. So fingers crossed that's the way it's going to be. So at the moment I'm setting this up. So what I did for a start was I bent these flared up sections here until I got the diffs, the empty diff casings, there was nothing in them, until I got a straight edge across the two diff casings, and I think you can see there, they line up. Okay, I spent a lot of time just flexing these chassis, bending them one way, bending them the other, until I got it absolutely right. So this diff casing here is facing that diff casing there. Then inside this built up diff there's one of these, which is the differential. The bearing fit is rubbish on these, and they slop around, put it in the right way, they slop around forwards and backwards. I don't know if you can see that, let's see. So you can see that bearing is loose in its cup. So I'll make these. They slip over here like this. This one is broken, that goes onto that layer like that. It's a lot tighter fit than that when you get it right. That one is not good. One on either side, and what that does is these differentials, get close so you'll be able to see it. They can go side to side, yeah, so it takes all that side to side movement out. It takes all that forwards and backwards movement out as well. Not the C-cups at the end here. These C-cups have to have a bit of playing anyway, so don't worry about the C-cups. It's the bearings that we're looking at there. And you can see they go forwards and backwards. So that takes all that play out there. Once you've done that, the drive shaft's too long. So after I've fitted this up, hear it clicking. It shouldn't click. It's only clicking because there's no gap in between the gear mesh. So you can hear that one's clicking straight away as well. So I had that perfect with no bearing covers on it. As soon as I put the bearing covers on it, it's made it worse. It's made it tighter again, and that's because the bearing covers have lifted it up 0.15 of a millimetre, and lifting it up 0.15 of a millimetre made all the difference. So I've got to take the drive shaft out now again, take that screw out the end just there, whip this gear off the end, and I should imagine I've got to take around about 0.2 of a millimetre off the end of the drive shaft on this side to give it the clearance so it doesn't click anymore. It should just have a bit of play in it, so when you rock the shaft, it should go tick, 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 but it's not. But anyway, slowly building that up. Here is me toy, and it's just on an accident where I ripped the back suspension off. And I rebuilt it upside down. So what I did was I turned it upside down, took every single screw out, and just took the chassis off and left the whole thing together. Rebuilt that side, and then put it back together again. And unfortunately, I've got to do that now to this. So I've got to take the top end off. So this top plate here, which looks much like this, top plate here. Take that off. Everything's attached to that, so the motor and everything comes out with that. Then I've got to set the prop shaft, not everything, it leaves the chassis looking like that with the prop shaft and two diffs in it. Oh, and the steering servo can stay in there as well, but it doesn't, it comes out with it the way I do it. Anyway, needs setting up again. So the upgrades in this, I've put bearings in there. I don't know if you can see that. I haven't put 3mm screws in it yet, but I've got bearings in them and it's made it a lot better. Got a Hobby Wing 120 amp electronic speed controller because I blew up this 120 amp speed controller, which is a direct copy of that. It's exactly the same, but obviously with cheaper components in. I've just ordered another one of these. I believe this was a faulty one. As soon as I put 3S into it, it blew up. But it didn't even run the car above 2 miles an hour. It just blew up straight away with 3S in it, and it shouldn't. It should run 3S. Anyway, got that. I've got a Fly Sky receiver in it. It is the FSBS6. I've made an aluminium stanchion here, and I've made a 3D printed twin body mount system here. I've made another aluminium stanchion here at the front and a single there. They align the body shell. The body shell is now battered. It got painted, it's now battered. The body shell is aligned by the pins and held on by Velcro. I've got a 3660 motor in it. It's 4300 kV. It is 100 amp continuous rated. It produces, this setup here produces 1.32 kilowatts at full power. That is 2 horsepower in total. This car weighs 2.5 pounds. That makes this 1,580 horsepower per tonne. It is fast, lively, fast, agile, really, really fast. Without the gyro built into this receiver, it is undrivable, completely undrivable. As you can see, it's been down the road. I constantly wheelie it. This is the second wing it's had on it, third wing. I need to make a wheelie bar for it. It is an absolute animal. Just running the standard 35C battery here with 2S. It's fast. It pulls wheelies, flips over, does a standing flip. It's a madman. I've got a 60C2S battery. It goes completely wild. I've got a 60C3S battery, and it just rips itself to pieces. It bends. It twists the drive shafts. Literally, the drive shafts here, they just twist up into little S shapes when you give it full beans on. And if you give it full beans, it either flips on its back or bends its drive shafts. So I've got hardened steel drive shafts which I haven't fitted to it yet because I'm not up to running it on 3S yet. So that was smooth until I did this final rebuild. Now I've got a sticking point, which means the diff and the axle, the prop shaft, the drive shaft aren't lined up. That's what it was like that. The front bearings are balls. It does a run per bearings at the moment because it produces 750 brake horsepower, no, 1,000 brake horsepower per tonne with 2S and nearly 1,600 brake horsepower per tonne with 3S. It is an animal. These things, Wltoys 144001, complete madman. You have to Loctite everything on. Oh, the other thing is the shock absorbers, I filled them with, you'd probably call it Slick 50, I think. I can't remember what it's called now. I'm trying to think what it's called. It's a friction reducer, oil and 30 weight engine oil. It's all mineral oil inside it, and they are silky smooth now. It used to roll like buggery, but with 30 weight mineral oil in it. It's SAE 30 weight classic motor oil I've got inside the shock absorbers, and it's brilliant. Literally, it's planted. It just feels planted on the stock springs. I have got more springs on order. I have tried some springs in it already, which are too stiff and too springy. But anyway, got 3D printed bushes in the back there now. I'm waiting for the proper ones to come, so I just 3D printed some to get me back on the road again. So I'm going to smash it up again. So that's what I'm doing, having some fun with the RC cars and having some fun with the 3D printer, because this is looking awesome. Anyway, I will be getting back into the garage and start getting the milling machines moved around, getting the concrete floor down, put the doors in, and hopefully getting the garage finished as soon as possible. Like I said, I've got to build this nuclear reactor. And I want to have it done by 2025 because that's when they're on about getting the International Thermonuclear Experimental Reactor in France up. Short for that is ITER. If you know anything about that, I want to beat them to fusion. That's what I make me to do. Anyway, I'll have a nice video up soon of something interesting, something wacky, you know, my usual stuff, something that's not normal, but still interesting.